Yes, good morning to all. Am I audible? Yes, just okay. So in the last class we discussed about the loop unrolling technique. Okay, we will continue with the same. Okay, so loop unrolling technique. Okay, I hope the screen is visible. So here, like to reduce the delay in the execution of an instruction. Okay, so the compiler will handle this task. Okay, compiler, how the compiler can increase the amount of the instruction level parallelism by transforming the loops. Instruction level parallelism. ILP means instruction level parallelism. How parallelly it executes the instructions. Okay, by transforming the loop, because the loop instructions, like they repeatedly execute the same instructions. Okay, suppose there are I is equal to 1000, means 1000 time it executes the instruction, right? So in such a, okay, okay, so this is the means the same instruction it is converted here, right? Now this is the here performing the initializing the value and comparing. Okay, and here the array addition is there. Okay, addition and store the result, and here decrement operation, subtracting. Okay, so the same instruction is written here: load, addition, store, then decrement operation. So here this particular the 5 instructions. Okay, the 5 instructions, these load. So these 5 instructions that creates some delay. Okay, so in the MIPS, in this particular MIPS pipeline. Okay, MIPS pipeline, this MIPS processor, it introduces some delay. Means suppose if the load instruction, okay, here it is, they are given a table. Suppose if it is a floating point arithmetic logical unit operation instructions, then it creates a means it takes 3 clock cycle. It is supposed to take 1 clock cycle, but it is taking the extra clock cycles if there is a floating point arithmetic operation. Then for if the source instruction is a floating point arithmetic and user instruction is a double store operation, okay, then it is taking the 2 clock cycles. Then load double, the instruction taking 1 extra clock cycle. Then load double, the user instruction is a store. If there is store, it is not taking any extra clock cycle, 0 latency. Okay, okay, if the user instruction is a store double, then it is not taking any extra clock cycles. Okay, so here you can observe this load the data. Okay, here loading the data. So load operation is there, no, this there is a one stall, and here some floating point arithmetic operation is there. Add means it is a ALU type of instruction. Okay, arithmetic logical instruction, and it is performing the addition of F0 F4 and storing the result into this F4. Okay, so there is some store operation is also there. Then it is taking the two clock cycle. Here one clock cycle, here two clock cycle, and for store there is no delay. Okay, and the loading the operation means some arithmetic operation here. So it is taking the one. Here arithmetic means it is performing some decrement operation, increment, decrement. Here it is decrement. Okay, R1 minus 8 means it is decrementing 8 data bytes. So it is one clock cycle. Okay, so just keep in mind with respect to this instruction, with respect to this, okay, it is introducing the some delay. So to total how many instructions are there? One instruction, two, three, four, five instructions, and the delay is 1, 2, 3, 4. So total to execute this particular loop in one iteration, it is taking the 9 clock cycle, including the delay. Total it is taking 9 clock cycles. Okay, for one iteration, because this original instruction is there. No, here I is equal to 1000. Okay, I is equal to 1000. So it is taking the 1000. I is equal to 1000 means 1000 time it performs a loop. So in one iteration it is taking the 9 clock cycle. And how many stalls are there? 4 stalls. In the loop, the execution with scheduling means the compiler what it does now to avoid the 4 stall. Okay, the delay was there, no, avoid the stall. Okay, यहाँ जो delay हो रहा था. Okay, so to avoid that stall or delay in the execution instruction, so compiler what it does, it is, and it separates a dependent instruction must be separated from the source instruction by a distance equal to the pipeline latency. Means कितना time लेता है उसके हिसाब से it will separate. Okay, it will find out the dependent instructions. It find out the dependent instructions to avoid the delay. So here in this particular case, okay, so in this particular case you can observe this is the first instruction, load, then after that stall is there. So the compiler it rearranged the second instruction is this one. It is shifted to this place because here the okay, and here this particular instruction it is performing decrementing the content of R1 register. Okay, so here it is loading and here it is, so there is no dependency here. Okay, there is no, here it is leading with F0. Okay, and here it is decrementing the R1. So इसमें just load हो रहा है. Okay, here there is no performing addition, subtraction वगैरह, there is no such operations. Okay, so the compiler what it does, it will keep in that particular delay slot this decrement operation instructions. Okay, then there will be same as it is. So by moving that particular this decrement to the second place, okay, now this particular the loop Okay, it contains 3, 4, 5, 6, 7. Okay, the total 7 clock cycles are required. Okay, 7 clock cycles are required to execute this particular loop. So dependent instruction must be separate, okay, from the source instruction. So here this independent instruction, this decrement is there, no? This independent instruction is added at the second position. So like earlier it was the loop instruction was taking 9 clock cycle. Earlier it was taking 9 clock cycle. So वहाँ कितना था 5 instruction plus 4 delay, 4 stalls. So total 9 हुआ. Okay. Now here, okay, and in that 2 stalls. Okay, means 5 plus 2, 5 plus 5 instructions and 2 stalls. So then it performs loop unrolling. So what the loop unrolling? Loop unrolling means what? This. So the compiler what it does, in one iteration we are in one iteration it is taking the in one iteration it is taking the 7 clock cycles, right? एक iteration में कितना ले रहा है 7 clock cycles. So in loop unrolling technique what it does, it will replicate, it will duplicate this particular instruction 4 times. It makes 4 copies. Okay, this load, decrement and addition, these instructions are there, no? It will make a iteration. So here it is 1 copy. Okay, actually in the loop instruction if you see the original instruction, okay, it has to perform the I value 1000, so 1000 times it has to perform the loop. Okay, so now with by rearranging the instruction we are getting the 7 clock cycles in one iteration. कितना आ रहा है 7 clock cycles in one iteration. Okay, so the compiler what it does, it will replicate or duplicate the copies with 4 copies. Okay, so this is the load and this one, load, add and store, will make a copy. Okay, copy means what, like here it is rearranging the instructions. यहाँ क्या करता है, the compiler will do this, it will take the load instruction, then addition instruction and store instruction, 3 instructions, and this is 4th and 5th, total 5 instructions are there. Is 3 plus 2, 5 instructions. Okay, a compiler will rearrange with register renaming, with it rename the registers. Okay, and it won't affect the result. तो यहाँ क्या हो, so loop unrolling with 4 copies. So this is 1 copy, this is the second copy, third copy and 4th copy. Okay, so there are 3 branches and 3 decrements of R1 have been eliminated, and the loop will run 27 cycles including the 13 stalls. Actually compiler is arranging in such a way that, okay, here you can see here in the first copy there are 3 stalls are there, second 3 stall, here you can see the stalls. Okay, 1 2 कितना होता है 3 into 12 plus 1 13, there are 13 stalls. Okay, 13 stalls, and normally instructions कितना लेते हैं 1 2 3 or 12. So here it is taking 27 cycles, 27 cycles including 13 stalls in one iteration, Okay, in one iteration. So okay, here ये जो है फर्स्ट इंस्ट्रक्शन लोड, सेकंड, थर्ड, और ये जो दो है फोर्थ एंड फाइव, द सेम इंस्ट्रक्शन इज रिप्रेजेंटेड हियर. हाँ यहाँ मीन्स इफ वी एग्जीक्यूट बाय लूप अनरोलिंग, यहाँ फर्स्ट इंस्ट्रक्शन है, सेकंड इंस्ट्रक्शन, थर्ड, और ये फोर्थ इंस्ट्रक्शन है, फिफ्थ, और ये तीन फर्स्ट इंस्ट्रक्शंस को डुप्लीकेट किया है. लाइक इन वन इटरेशन वी आर एग्जीक्यूटिंग 4 कॉपी. ओके, तो यहाँ क्या हो रहा है, इट इज टेकिंग द 27 क्लॉक साइकिल in one iteration. Okay, so here the compiler what it does, okay, ये जो है instruction in every loop there is a load is there, ये copy. Okay, तो compiler क्या करता है, it will rearrange the instruction, it will place all the loops here, one second loop, there are 4 copies were there, right? Add 1 2 3 4. Okay, and it is rearranging, यहाँ rearrange कर रहा है, 1 second store, third store, fourth store. Okay, this loop will run in 14 clock cycle without any stall. There is no stall here because first it is executing all the loop like load instructions. यहाँ पहला कैसा था, यहाँ there is see here there is a dependency is there, load, and here add instruction is there. No, it is using the this registers, there is a dependency is there, so that way it is creating a stall. Okay, ये जो ओरिजिनल इंस्ट्रक्शन है यहाँ. Okay, here this f naught register is there, this add instruction is using that f naught. Okay, so that's why here even store also, here there is a dependency. यहाँ भी addition कर रहा है और यहाँ भी it's storing the content, so some dependency is there, so that's why compiler what it does, it rearranging the instructions. Okay, rearranging the instructions. तो पहला कितना था 27, ये जो केस में है, इन दिस पर्टिकुलर केस यहाँ देखो ये जो विथ इंक्लूडिंग ऑल द स्टॉल्स 20. Okay, now we rearranged some like separating the dependent instructions and all, so it is taking the total 4 4 8 8 4 12 12 to 14 14 clock cycles it will take without any stall, there is no stalls. Okay, so this is possible with only loop unrolling technique. तो पहला कितना ले रहा था वो with stall 27 cycle. So this is reduced in one iteration. Earlier it was taking 27 clock cycle, now it is 14 clock cycles. So the loop will run in 14 clock cycles without any stall. So it requires the symbolic substitution and simplification gain of 22 clock cycles. So loop unrolling with the scheduling. So the decisions are decision means how to identify the independent instructions and all. Okay, so identify that loop iterations are independent. The loop iterations are, the compiler will do this. Okay, the loop iterations are independent. Use the different registers to avoid unnecessary constraints. This is one very important thing. It uses the different registers. The registers here you can see, observe. So it is renamed the register F0, F10, F14, F6, F12. The registers are different, and eliminate the extra test and branch instructions, and adjust the loop termination and iteration code, that rearranging the instructions, determine the load and stores that can be interchanged in the unrolled loop, because load and store, these deal with the memory related instruction. Both are memory related instruction. Okay, load and store. So schedule the code preserving any data dependency needed to avoid the need to lead any result as the original code. Rearranging the instructions. So the key requirement is to understand that how the instructions depend on one another and how they can be changed and reordered. So that is very important in loop unrolling. Okay, how the instructions are depend on one another, dependency of the instruction, and how they can be reordered or rearranged. Okay, so that is very important. So loop unrolling with scheduling, there are three different types of limits are there. It decreases the amount of overhead with each unroll. The growth is, yeah, the size is increased. The size of the code is increased due to the unrolling. You can see here, this particular size will increase due to the unrolling. Okay, and shortfall of registers. As we rename the many as a register, so shortfall of the registers created by the aggressive unrolling and scheduling. Because we use many registers, so that is the register pressure. Loop unrolling improves the performance by eliminating the overhead instructions. Overhead means some dependent instructions. Loop is a simple but useful method to increase the size of straight line code fragments, and it is very sophisticated high level transformation that lead to significant increase in the complexity of the compiler. So all these decisions and all that is taken by the compiler. Compiler will identify the dependent independent instructions. It will rearrange the instructions to avoid the stall. Okay. So this is all about the technique that is called as loop unrolling technique. So loop technique, as you can, this is the original code. Okay, the loop instruction, two lines of original code. Okay, so this two lines of original code is converted into this assembly language, 5 lines of code, and here with dependency, because of the dependency, it introduces stall or delay in the instructions. Okay, so the same, the with 5 instructions, by rearranging the instruction. Okay, and dependent independent instruction. Earlier, nine clock cycles will take this particular instruction. This rearrangement will take 9 clock cycle. So the compiler will rearrange the instruction, and it is reduced to 7 clock cycles. Okay, by shifting the independent instructions. Then the compiler, what it does, it will unroll means what, it creates a copies. Okay, 4 copies in one iteration. Okay, it depend, it is not only 4 copies, it depend upon, it is just for your example purpose they are mentioned, like loop unrolling with 4 copy, loop unrolling with 8 copy also can be done. Okay, it depend upon the instructions. So in one iteration we execute instructions. Okay, and it is taking the 27 clock cycle with the stalls. 27 clock cycle with a stall means delay also, because there is a dependency there. Okay, next the compiler, what it does, it will rearrange the instruction. So here all these the decisions, that all it is taken by the compiler. Compiler will handle these like unrolling and rearranging the instruction. Okay, so the main thing is to avoid the stall. Okay, earlier it was taking 27 clock cycle, but that is reduced to 14 clock cycle by identifying the dependent independent instructions and all. Class, as we discussed, data forwarding technique. Okay, to overcome the hazards and data hazard, and this particular compiler loop unrolling technique. Okay, loop unrolling technique, that is to overcome the data hazard. Okay, and there is one more technique is there that will to overcome the control hazards and all. Okay, that we will discuss in the next class. Okay, so you can leave and we will discuss in the next class, and try to complete the